Student, let us see what is there in this question. A model of an ideal wind turbine of the blade length L naught is designed to produce a power P when the average wind speed is V. The second windmill, ideal, is designed to produce the power of P by 2 when the average wind speed is V by 2. What is the blade length of the second wind turbine? So, my dear student, I can directly jump to the formula and then we can go for the solution. But before that, we must try to understand what is an ideal windmill. Ideal windmill is that, let us say, there is a wind which is moving with the velocity of v. This is an assumption that if it is going to cross a windmill now, so all of the energy which was brought in by the windmill, by the wind up to the windmill, all of the energy is converted by the turbine. It means that wind velocity after it passes through the windmill becomes zero. This is a complete hypothetical case. Obviously, it never happens like that. Like the wind is blowing, and when it passes through the windmill, it stops blowing. So that hardly happens like that. So let us say the power input is P input, and so the condition is for the ideal turbine that all of the power which was contained in the wind is being converted into electricity. Never happens like that, but anyways, this is what is an ideal windmill. So now we are coming to the formula, which is rho a v cube. As I have already told you, there are three formulas in the case of windmill, that is dm by dt is equal to rho av. Rho is a density, it is a Greek letter rho, so don't call it p. Many students call it p. This is not p, this is rho. Now the force is rho a v square, and the formula for the power is half rho a v cube. Now case number one, it is said that in the first case the length of this is, so I will say the power is p, the velocity is v, so this density rho, so the length is L naught, so area can be written as pi L naught square, pi r square, into the velocity is given as v cube. This is the power in the first case. Now case number two, now the second ideal windmill is designed in such a way that the power produced is p by 2, half rho, area, like length is not known, so basically the area is not known, so I am just calling it pi L square. Let us suppose that the length of the blade in the second case is L, which is actually unknown to us, so I'm just calling it pi L square, and the velocity will be v by 2 cube, because now the velocity is v by 2, power is p by 2. So this is our final equation. So we want to equate these two equations, and we want to find the value of L in the terms of L naught. This is what we want to do. Now how can we do that? This half and this 2, I can just cancel it out, and this P is equal to this P now, because it was P by 2, but P 2 has been cancelled, so I can just equate these two equations. This is what I'm going to do here. Half rho pi L naught square V cube is equal to rho pi L square V cube divided by 8. And from here, rho pi V cube can be cancelled because they are same values. 8 can be taken to the other side and 2 can cancel this. It will become 4. Clearly, L square is equal to 4 L naught square. So the answer is C. Hence L, taking square root on both sides, the answer is C. This is how we solve this question. So whenever it comes about the windmill, like the question is about windmill, always remember there are only three formulas that you need to consider, and for the power there is only one straight formula. In the topic of energy production, that is 8.1, I tell you there is no mathematical formulation in coal-fired power plants, no mathematical formulation in nuclear power plants, or in solar power plant. There is no mathematical formulation. So if there is some math involved, it has to be a windmill, and if it is a windmill, it has to be this formula, that is half rho a v cube. Simple and straightforward. Just learn it, plug in the values, and get the answer. So thanks for joining, my dear students. This is Professor Varun. Thanks for watching the video. Please subscribe to the YouTube channel. Also join the YouTube channel if you want to access the paper 2 questions. All the best. Bye.